Well, thanks everybody for coming in for my presentation today on data pipelines with Ceph Object. My name is Kyle Bader. I'm a principal portfolio architect for Ceph offerings at IBM. And as I'm going through this, if anyone has any questions, just kind of we can interrupt and go into it. I think we'll have enough time. All right, so I don't think this is even controversial at this point. We've kind of moved to a new world when it comes to analytics and data processing, where it's not even unusual. It's actually the expectation that most folks would be interacting with an object store for their data. I remember in maybe 2017, we used to kind of argue for the benefits of using a single shared object store and then having multiple on-demand analytic clusters. But that's kind of just more the norm now. In fact, you'll even see some of the cloud eras of the world are even moving to object storage in the future. One of the things that is really nice about an S3-based object store, and in particular, the implementation and coverage of the S3 and adjacent APIs that is provided by Ceph, is that it gives you a lot of rich capabilities in terms of managing the data. So you have bucket policy, you have life cycle, you have IAM, and a number of other things that you can use to help with data management beyond just storage, right? It really moves into more sophisticated access control and life cycle of data, transitions, et cetera. In this kind of world of having a shared object store for your data lake, there's often a variety of different applications that are off to the side. Not everything is coming in through like a single verticalized analytical environment. A lot of times you have applications that are directly interacting with the S3 APIs and storing objects. You have streaming. You have streaming technologies like Kafka, and then consumers that are constantly pulling stuff out of those topics and then persisting the data into the object store. And you have all sorts of different tools that are analyzing the data, processing it, training or performing inference on the data. And so it's getting more and more interesting. Beyond just the object APIs, the S3, the Rados gateway in Ceph also has the ability to run an NFS server. So it uses Ganesha, and then in the back end, it uses librgw, so that you can have a file-based access modality to objects that are stored in the buckets. There are some caveats with regard to the types of operations you can perform. Usually has to be a whole file, right? You can't do kind of appends, that sort of thing. But it serves very well as an additional way that you can on-ramp data for applications that you might not be able to rewrite to use object SDKs. But kind of the really interesting thing about object storage is it goes beyond just being a simple file system, and that you start to get more and more capabilities that kind of lend to data engineering type tasks. And so instead of only using data engineering tools to accomplish some of these things, you can actually use some of the more sophisticated features of the object store. So there are some examples here around the access. I spoke about the NFS access, but there's also a number of other ways that you can access objects, right? So we have both S3 and Swift APIs. We've done a lot of integration work over the years with the S3A file system client from Hadoop Common. And that's used by not just Hadoop, but also by Spark. So if you're interacting with data and you want to interact with it similar to how you've interacted with, say, HDFS in the past or a local file system, you can use the S3A file system connector and interact with the object data. And that's fairly handy. for data availability and for kind of ensuring the survivability of data, we've done a lot of work. There's been several really great presentations about folks that have been using multi-site replication. And that's been around for a while, but it's really kind of crossed the Rubicon in terms of being able to kind of scale and get past some of the issues that were present in earlier generations. There's a new kind of capability, a relatively new capability called Archive Zone. That is kind of where you can set up a multi-site topography where you have a second site, and you keep copies of, and you send off copies of the objects to that site, so that if there was, and it does that for all the different versions. So it kind of has a history of all that, and it can be a cloud-based, site, or it can be another object-based site. And so that's kind of like an additional tool that you can use for ensuring that your data stays there. In the management space, one of the things that we identified from some of our early conversations with customers that were doing kind of more sophisticated analytics is they really needed to do access control, and they wanted to be able to do some access control at a finer granularity at the storage level, so that they didn't have to always push all the data processing through a policy enforcement point, and instead they could have applications that are accessing it directly. But in order to do that, they need to be able to deal with complicated things where, say, you have data that's colored one way in terms of who can access it, right? So you have red data and then you have blue data. Well, kind of the simple thing is, well, you could have people that could access the red data and blue data, and you could do that by, the naive way is to just have a set of credentials for one bucket and put the red data in the red bucket, and you have a set of blue data and you put it in the blue bucket. But that doesn't work, because then you're sharing credentials. Well, you can switch to doing something that's role-based, where you have a principal, and then you can either become, assume a role where you're blue and you can read the blue data, or you can assume a role and be red and read the red data. But what if you need to join? What if you need to do a join on data, and that data is in red and blue? So what you actually need is attribute-based access control. So you need something that says, this principal is actually able to access red or blue data. And we've gone to the point now with our STS and IAM implementation where you can implement that in connection with the OpenID Connect provider. I'll go into that a little bit later. But you can see we're doing and adding capabilities to the Ceph object store to really tend to the data management type use cases. And yeah, we're kind of squarely targeting like the data engineer here in this part of the talk, where we get into the pipelines. So kind of getting onto the real core meat and potatoes of the talk is kind of before data pipelines, perhaps, you have folks that are storing data, and then people are potentially discovering that data and then looking at it, processing it, and this is all kind of a manual process. The initial automated way that you could improve upon this, absent something more sophisticated, would be to set up an application that's just pulling a bucket, and then when it sees something that's interesting, it can do some sort of process and make the data available for wider consumption. But there's a better way. And that builds off of the event notification, or the bucket notification feature that is now, or has been for a number of years now, part of the Ceph Rados Gateway. So what you can do is, if you can create a policy, and then you can use the put bucket policy S3 verb to go ahead and set that policy for a bucket. And in that policy, you specify a notification, where the notifications should go. And we supported a number of different targets for these notifications. The three most popular are sending it to a Kafka topic, sending it to AMQ, or sending it to a REST API. And this becomes interesting because then as data is written into your buckets, you can dynamically, or you can have kind of an event-driven architecture, and you can start to do more interesting things. Now, so once you have a message going into Kafka or a Kafka topic, or if you're having it send a notification to REST API, you can actually trigger other things. More interesting integrations are when you integrate this with some sort of serverless type system that can scale to 0, and then as additional events are generated, it can scale out more tasks to be able to process it in real time, and then it also has that kind of, it scales up, scales down automatically without you having to do, kind of manually size that, right? Or if you're doing something with just like a REST-based API, right, where you have a single application like running in a Kubernetes pod, and it was consuming those notifications and then doing stuff, you would have to figure out a way to scale that. Whereas if you kind of use if you set it up with kind of like a serverless runtime, then you don't have to worry about the scaling so much because it will handle that for you, right? And it can go down to 0 so that when there's not new data, it's not actively consuming resources from, for example, your Kubernetes cluster. So one example that of kind of tying this into a serverless framework would be Knative. And so you can configure Knative to basically be monitoring the Kafka topic, where Ceph is sending the bucket event notifications, and then when a bucket notification lands in that topic, Knative will go ahead and fire off a function that can then take that notification, which is cloud event, has information about the object itself, the time of the event, and then it can do something interesting. And so this isn't, so instead of doing a pull-based approach, or instead of having like a daily type job that does something like this, you can do it reactive. It can be real time, and it's really efficient because you don't have you're not having something that's constantly running and polling, that's taking resources, both on the incurring load on the object store by doing these listings over and over and over again, but also you don't have that actual application running and then worrying about its availability and that sort of things. Instead, it's all tied into serverless functions. It's event-based, and it can like scale up automatically based on the load and volume of notifications. And it decomposes things into kind of a more microservice-y type data processing pipeline. So interestingly, one of the demos we did early on of this capability with Ceph, and we wanted to combine it with Knative inside of well, in this case OpenShift, but it could be any Kubernetes. We did it based on medical imaging, X-ray imaging, and we started building this demo around at the beginning of the year in 2020, which was kind of interesting because we were doing like pneumonia risk analysis of X-ray imagery, and then like in the ensuing months, COVID happened, and so it was kind of it was just kind of interesting that we were doing like lung X-ray right before this happened. But the idea of our demo, which was inspired by one of my colleagues, his wife worked in healthcare and healthcare research, and so we came up with this idea that what if we took X-ray imagery and we put it into a bucket, and we had configured notifications on that bucket. We could then use a model, right? We could take a pneumonia risk model that we had found, and we could kind of bundle it up in a Flask app, and then every time a new X-ray was uploaded into the bucket, we could have that model basically do an inference against the image, and then take the resulting score from that inference, which is a pneumonia risk score, and then we could add it as a tag. We could add it as a tag to the object, or we could anonymize the image, or there was all sorts of things that you could do here. And in this case, we ended up doing a risk score, put it onto the object, and if it was over a certain threshold, we did some anonymization of the image. So like finding like the patient, like basically do a bounds check to find like the patient's identification like in the corner of the X-ray, and it would block it out, and then it would store it into another object store that was like kind of like the central lab where like the kind of scenario that we were kind of envisioning was like you have like a central lab where you have people looking at the high risk ones so that they can assess and see if there's special care that's needed from the patient. And this is a made up scenario that we're but it has practical implications, and as we kind of talked about doing this and we started doing demos with this, there were a few different institutions that approached us and they're like, we want to do something like this. So that was kind of cool. I think it helped, and actually the entirety of this, we have like the code to set up to do this demo on GitHub. So if anyone's interested in this, we can share it. But also part of the demo is we built a Grafana dashboard that would show the updated X-ray imagery that was from the most recent ones, and then we have this nice kind of shows the overall pipeline. And then, the statistics around the incoming feed of images that are coming through and being and having inferences performed against them. But this is like more widely applicable, right? Like it's not just imagery analysis. You can do this with all sorts of data, right? So if you have something that's emitting sensor data, it's occasionally uploading CSV data from some sort of sensor, you could be triggering functions that are basically doing some sort of operation on that CSV data. So it could be doing filtering, it could be doing actual analysis and then storing summary data. It could be doing more complicated like inference using a machine learning model. And you can potentially chain them together in multiple stages. We did another demo where, like an anonymization-based one, where we were uploading data, and so we kind of, instead of doing the pneumonia risk score and the anonymization, we made it more simple, where it was like, you say you have like street view type imagery, right? And you're dumping imagery into a bucket, and you just want to filter out certain things. You want to filter out people's faces. You want to filter out license plates. You want to filter out signs or something to make it more to anonymize it. And it's kind of the same sort of thing, right? Where you can set up these bucket notifications. You can have something that's consuming them, and then provisioning the serverless functions for each event that gets driven, and then it can either use perform some sort of inference or other operation, and then in this case it was replacing after it did the bounding around the image, and then basically doing a mutation on those pixels. It would then store it back into the resulting bucket, replacing the original image. But there are all kinds of things, right? You could, it could be PCAP data, and maybe you're doing an inference to see if there's malicious like traffic flows in it, or I don't know, like say it was telemetry data, right? Telemetry data comes in. You could potentially take that bundle of data, and then you could do some sort of assessment of it, and then so for every time a new bundle of data comes in, you crack it open, and then you're performing some sort of analysis or inference against it. So it's really up to the user what sort of creative things they could come up with. Kind of more pedestrian things might be like serialization type things, right? So say you have an application that you don't really have a lot of control over, and it's constantly uploading CSV data. Well, that's not great, right? Probably would be more useful if it was serialized in a different format like Parquet. So like you could have a task that whenever a file is uploaded and it matches basically a path that has CSV in it, then you could trigger a job that would run something you had written like in PyArrow or something that'll take that CSV data and then write it back out as Parquet and then delete the CSV version. And now you have taken that kind of inefficient text data and then serialized it in a binary format that you're going to be able to query more rapidly with your analytical tooling, and it's compressed, and so end up saving a whole lot of space. The other interesting thing that can dovetail into this is Ceph has this capability to do secure token services. So it's kind of like you can think of it as an S3 adjacent API if you're unfamiliar with it, where instead of signing your S3 requests with your access key and your secret key, you can use your initial credentials to request a token, and then you use that token to sign it, and those tokens, and then you can rotate through those tokens. The interesting thing about the tokens, though, is that when you request a token, you can assume a role, and when you assume that role, that role can be used in bucket policy and IAM policy. So instead of me, if I'm a data owner and I'm writing a bucket policy, I don't have to say that Joe, Bob, Tom, and Sally are all able to access my data, and then when there's someone else I need to add or someone else I need to remove, I have to keep on updating my policy documents. That's fairly inefficient. The better approach is to define which roles or which attributes lend to the access to the data. And so this is really nice. So then you can set up a credentials provider in the by creating a credential provider through the IAM API, and then you can associate that with like policy. So you can say like these users. So if you have an OpenID implementation, and that can provide basically a mapping for a particular principal to a role, right? So if I go to my OpenID, and then I can basically use that, and they can go, oh, okay, Kyle, he's a principal architect guy at IBM, so here's the bundle of things that he can access, and then that can map me to roles that then allow me to access certain objects. Now, bucket policy can also do role-based access control, and that role-based access control can additionally be keyed off of labels. And so if you can see where I'm going here with this, is that if you have data that's coming in and the data is unlabeled and it triggers events, and then you're doing something interesting with it, well, you could do inference against the newly added data, and then depending on the result of that inference, you could add labels, and those labels then allow people to access it. You know what I mean? So you're basically able to do some sort of inference action that whitelists the data to certain principles, which is really kind of interesting. So if you have new data that's coming in, and maybe you need to do some sort of anonymization, or you need to do some sort of data masking, or if you need to do some sort of filtering, right? So maybe the raw data, certain principles can't access. But if you filter out certain columns of the data, then other principles are able to access it. Or if you anonymize it, or if you mask out the data, then other principles are able to access it. And so you can kind of set up these more complicated workflows that integrate with identity in such a way that you're really doing some fairly neat stuff just with the capabilities of the object store, right? You don't have to bring in like something like an Apache Ranger and a policy enforcement point in order to be able to do these kind of richer things. You can do it pretty much with fairly pedestrian, like little kind of microservice apps that you write with Go or Python or that sort of thing, and just the capabilities of the object store itself. Now, a relatively recent feature that I think is that I think also kind of is like pairs well with this is bucket inventory. That sounds really, really boring, right? It's like, okay, I get an inventory in my bucket, right? It's like, oh, I can do a bucket listing, right? What's the big deal with a bucket inventory? Well, the nice thing about a bucket inventory is the bucket inventory APIs, you can say, okay, I periodically want an inventory of this bucket, and I want the resulting inventory of that bucket to go in this other bucket. Well, if you have a different, like say I have another bucket where I'm going to send all my bucket inventories, I could set up notifications on that, couldn't I? I could. And so whenever a new inventory arrives, I can then have something that's going to go through that inventory and perform tasks. Well, what if I was triggering something like an airflow job that was going to go through that inventory, and then per item in the inventory, if it matches a particular thing, I can then have that become a task in a job, right? So if I have a bunch of files that I want to do a transform on, and I didn't have the luxury of setting up this machinery before the objects were written into the store, I want to do some sort of processing ex post facto, bucket inventory gets really interesting because you can use that as a manifest to perform a workflow DAG of actions against all of the objects that match a certain set of keys or e tags or whatnot, right? And then so that's kind of interesting. You can look at the date. So there's all these different fields in bucket inventory, including the labels of the object. And so you could filter the workflow job off of that, and then perform operations where it's going to kick off like a function basically for each item that matches that in the bucket inventory. So that's kind of the new something new that I'm pretty excited about. And most people think, oh, bucket inventory, that's boring, right? But when you take bucket inventory, you take notifications, and you take the access controls with filter tags, you can do some really cool stuff. And I guess I would also add that that lifecycle too, lifecycle and the new basically replication rules, all those things together often have filter tag. You can filter off of prefixes and tags. So by moving objects around and labeling them in different ways, you can kind of trigger more advanced data management type capabilities, mostly using just the features of the object store and a little bit of extra. So kind of the overall idea is kind of watching the feature set, watching the expansion of S3 capabilities, and then strategically using the ones that can be connected together and that are more composable, right? And the ones that are most interesting when they're all combined together, right? So when you're able to do bucket policy, and you're able to do the IAM policy, and you're able to do replications and life cycles and notifications based on certain tags and prefixes, and you can chain all these things together and do a lot of really advanced and interesting data management type tasks. All right. That was really fast. I talk fast, I'm sorry. So we have plenty of time for questions if people have questions. Hey. Hello. Oh.
Kind of not related to this, but a question like, how does the mapping between an S3 user versus the principal token that you're talking about exist? Like, so I have an S3 user, he or she can then create a principal token, and then a principal user, and then this creates multiple tokens? Like, just trying to visualize the mapping.
Let's see. Okay. So the way that it works, and I could probably find a document so that you can refer to it. But the way that works is normally well, the simplest way to do it, right, is where each user has their own set of access key and secret key.
Correct.
And then through the IAM APIs in Ceph, you can go ahead and define roles, right? And then you can have IAM policy that dictates which users can assume that role. And then instead of listing users in bucket policy or IAM policy, you can list the roles as principals. So I can say that data scientists are able to access this bucket in this bucket policy, or I can say that the financial analysts or the security team are able to access this bucket or this bucket, but only this prefix, right? You can do all that in bucket policy, and so instead of using like named principals like Kyle or Yurit or whoever, right? So that's the most simple way. Now, if you don't want to be entering in all of the different principals, or if you don't want to be generating S3 credentials for every single user, what you can instead do is you can configure an identity provider. And so there's S3 APIs to set up the identity provider, and normally that points to, so we support assume role with web identity. So when you create the identity provider, it points to OIDC identity. And then you basically set up some IAM policy that dictates how to take the tag bundle that comes back from the OpenID attestation and then maps that to IAM roles that then you can use in bucket policy. Does that make sense?
Yep, makes sense. Probably having a documentation around makes
yeah, it's super kind of confusing the first few times you are going into it, and it definitely helps to really have it all written down and have examples and set it up and kind of see it and go, oh, okay, now I'm starting to get it, because yeah, it's easy to get confused.
But I believe there is one, right?
Oh, yes. Yeah, we have some examples.
Thank you.
Are these pipelines only limited for object storage, or can we have for RBD and CFFS also? The data is coming from them also, right?
Well, I mean, so a lot of these pipelines, they're triggered by notifications, and those notifications, usually the notification format is something called cloud event. And so the Rados gateway forms these cloud event notifications and then can send them to different targets. And so the Ceph MDS or the RBD itself, right? Because it would have to be in the OSD, would have to somehow have these some sort of capabilities. So I don't know if someone has written some sort of functionality through iNotify or something where they can monitor a file system and do something similar to this. But this is one of the things that I think is what makes object storage so interesting, is because it goes beyond kind of the interfaces that were defined 40, 50, 60 years ago in terms of POSIX. And instead, you have these richer, more developed interfaces where you can do things like notifications. You can do this more complicated policy and access control. You can do these things like bucket inventory, and it's an evolving API that's trying to keep up with the needs of people. And so that's why I think object is really interesting as an access modality for kind of new applications.
Thanks.
So I have a question about batch processing.
Yes.
So one of the issues with batch processing is that what if for scalability, you need more than one client that does the processing, and then it's pretty difficult to figure out if a record was processed or not, and who owns the processing of each.
Yeah, I mean, granted, this is not going to replace all sorts of data processing needs, right? So if you have really big, if you have this is more if you need to do some sort of per object transform, right? And it's going to be relatively lightweight, so it's a lightweight kind of thing. If you need to scan a petabyte table and then do some sort of transform on it, roll in Spark, right? That's what it's for. But if you're able to break it down to a per file granularity of processing, if you have relatively simple needs, then you can use this instead of kind of using the USS Enterprise of Spark to do something that's really simple, right?
Thank you.
Anyways, thank you everybody.